Alright, so this problem asks, which molecule has the R configuration? So it's stereochemistry here. So what we got to know is how to interpret these stereo drawings of molecules to determine R and S when drawn like this. Dashes, dashes means bond going into the page. Solid wedges, bonds going out of the page. So what we want to do, we got to number these by priority, right? And so how you determine that is you want to walk on out what's next bonded to this carbon, rank them, compare them, rank them in terms of priority based on highest priority is atom with highest atomic number, right? So here we come across O. O is higher number than, or higher atomic number than C's, H's, right? So then C, right? C here, these both are C, but then this C is attached to two O's. Well, this C is just attached to all H's. So O comes before H in terms of priority. So this is then the 2, right? That makes this 3, and this guy here is 4, right? And in order to determine R and S, the trick that I use, you want to, if the lowest priority group is in the back of the page, you just want to go around, turn around here, draw a line from 1 to 2. So that right there is a left-hand turn in your car. That's going to be S configuration, right? I remember if I'm doing a right-hand turn, it's R. So that leaves left-hand turn is S. So let's go ahead and rank this guy here. Here's an O. We got C attached to two O's, and C just attached to one O. So this guy takes priority 2, right? 3, 4, right? So if we go from 1 to 2 to 3, that's a nasty turn up there, right? But that, again, is a left-hand turn. So this is S configuration. And it looks like 5, but it's supposed to be an S there, right? So rank this guy again, right? 1, 2, 3, this guy's 4 here. So 1 to 2, let's go all the way around to 3, really show what we're doing. Our 4 group is in the back, so we can just go straight to R here. Right, so C should be our answer. Let's check. This guy is 1. This C is attached to 3 ends. Has 3 bonds to end. So that makes that priority 2, 3, 4. 4 is in the back, right here. Right, so that again is a left-hand turn if you make that motion on your car steering wheel. So that's S. So for all these, that leaves C as the answer. But for all these molecules, the lowest priority group was already in the back. So what you can do is, let's say our lowest priority here, CH3, was not in the back. What we could do is we could act as if it's in the back, right, at first, and determine the configuration of the molecule, RS, and then replace it with what has a wedge in the back, and then we'd flip the configuration. What I mean by that is, actually I should say, we would flip it first. Let's say CH3 was in the page here. We'd put it in the back, determine R and S, realize that by flipping any two of these groups, we change it from R to S, or from S to R. So then we just change the configuration, whatever we determined after we had flipped it the other time, change our letter, flip the letter back, and we get our configuration. Hard to show without an example. We didn't need to go into that detail in this problem. So I'll stop trying to over-explain here and in this video. Thanks for watching.